Hello everyone, you are welcome to this class. So today in this video we want to look at quadrilaterals. So we started with plane shapes. We looked at triangle. So in this video we are looking at quadrilaterals. So quadrilateral is a four-sided shape, plane shapes with four angles. We have six of them, and that's what we have on the screen. We have square, rectangle, parallelogram, rhombus, trapezium or trapezoid, then kite. Now, these six quadrilaterals have division. So some are parallelograms, while some are not parallelograms. We are going to deal with them one after the other with their properties. So in this, we're going to look at the first part is we look at types of quadrilateral that we have. There are two types. So we have parallelogram and then non-parallelogram. So the parallelogram are the squares. That is, they have the feature of parallelogram. That is, they have two pairs of opposite sides being parallel, just like parallelogram. So we're going to look at that. So square, rectangle, rhombus, and parallelogram, they are under parallelogram types of quadrilaterals. Then non-parallelogram are trapezium and a kite. So a trapezium only has one pair of opposite parallel sides, and a kite has no parallel sides at all. So that is what we have under this. So the next one is now we're going to be looking at them one by one after the other, and their properties. So the first one we're going to look at is square. So under square, so we're going to look at square. This is square. It is a column with four equal sides. So what we're saying in essence here is that square has four sides then equal. This side equals to this side, equals to this side, equals to this side. So that will be the first property of a square. So which we're going to look at now. So we'll look at that right now. So that is look at. So the first property is that it has four equal sides. So it has four equal sides. Equal sides. So that's the first one. So the second one is that uh, each angle, each angle, each angle, uh, each angle is 90 degree. It's 90. It's 90 degrees. All right. The other one is it has two pairs of parallel sides. It has two pairs because this side here. So if you look at this side here, this side is parallel to this side. So also this side here is also parallel to this side. So it has two pairs of parallel sides. It has two pairs of parallel. It has two pairs of parallel sides. I hope I'm making sense. So that is that one. Then, all right. So we have looked at parallel sides. Then we have to look at lines of symmetry and other rotational symmetry. We've discussed what lines of symmetry are in a previous video. That is a line that divides a shape into two equal parts. So in which one part can uh, fit in to the other part exactly without having extra. So that means this square, we have how many lines of symmetry? You can divide it this way. So we divide it this way. So this is one. This side will overlap on this side. And we can as well divide it this way, making two. Then this one as well, we can also cut it this way. We can as well cut it this way. So it has four lines of what? Symmetry. It has four lines of what? Symmetry. That's the next one. It has four lines. Four lines of symmetry. Alright. So it has four lines of symmetry. So that is the fourth properties of a square. So another one is order of rotational symmetry. So we can rotate it four times and it will still be the same thing because all the sides are equal. So it has four order four others, four other of rotational symmetry. All right. So I think that is that on that. Then the sum of quadrilaterals. What you should know under quadrilaterals, all the quadrilaterals that we have, the six of them, the sum of their angles is equal to 360 degrees. Note that. So all quadrilaterals here, we can have it here that note, note. So the sum of the sum of angles in a quadrilateral in any quadrilateral is 360 degrees. So it's 360 what degrees. So the sum of angles in any quadrilateral, so any of the one above, so will give us 360. So I don't want to be repeating this. So that's why I have to put it here. All right. So we all know that. But each angle will be varying as we move on. So move to the next. We are still under squares. So we've looked at the lines of symmetry. Each square has, which it has four lines of symmetry. It has four other of rotational symmetry as well. So what else again? I think that is all. So it has four equal sides. So it has two pairs of parallel sides. So the opposite sides are parallel and equal. So we can put it that way. So this one has covered that. So I think that's all. So move to rectangle now. So this is a rectangle. So under rectangle, all right. So rectangle to the opposite sides are equal. So it is a quadrant with two pairs of equal opposite sides. So this side is equal to this side, while this side is equal to what? This side. Let me put two here. So I'll put one here. All right. So this side equals to this side. So it has two opposites. We can put it. How many pairs of opposite side we have in this one? So it means it has two pairs of opposite side. It has two pairs, two pairs, two pairs of opposite sides. So that means the opposite sides are equal, and that's we have two of them there. Then that opposite sides are parallel as well. So we can have opposite sides are also what? Are also parallel. Are parallel. Alright? So that means that it has what? It has two pairs rather. There are two pairs of uh, parallel sides. It has two pairs of parallel sides. So whichever one you put is still the same thing. Is that clear? So that means we are saying that so is this side is parallel to this side. So that is the reason why a rectangle is a parallelogram, two pairs of parallel sides. So this is also parallel. So that is the same thing with square. So can it has two pairs of parallel sides, the opposite sides are parallel. That is the reason why square is also a what? Parallelogram. Is that clear? It's a parallelogram of a type of quadrant that is parallelogram. How that is very clear. So let's now move to what is it called? Pairs of line of symmetry. So a rectangle can be divided into two equal parts here. So you can divide it like this. This is one, and you can as well divide it like this, making two. So if we divide it this way, so this cannot overlap on this. This A cannot overlap on B. So in that case, you can't divide it that way. You can try it. When you try it, it will not. So let me withdraw this. All right. So this is all right. So this will not work. All right. So in that case, it has uh, two lines of symmetry. It has uh, two lines of symmetry. Two lines of symmetry. All right. I hope that is very clear. So that is that on rectangle. Which other one again we have there? So it has two order of rotational symmetry. We can only rotate it twice. So let me see, let me practicalize that for you. So let me duplicate this and let me bring it here. So let's rotate it. So if I rotate it, it's not exactly like what we have there. That is, I've rotated it first time. So second time is exactly like this. That is one. Then this is third rotation. It's not like that. So if I rotate it again, okay. So this is it again. So it has two order of rotational symmetry. It has two order of rotational symmetry. All right. I hope that is very clear. So that is that on that one. Then the fifth property we have there. So each angle of this one to each angle. So each angle is 90 degrees. So it's also 90 degrees. All right. So each other one again. So we looked at lines of symmetry, pair of opposite sides, and like that's all. So move to the next one, and that is parallelogram. Parallelogram, just like we have it in the other one. So this one too has, so it has two pair of opposite sides. So opposite sides are equal and parallel. We can put that way. So opposite sides are equal and what, parallel and parallels. So that means this side here is equal to this side, while this side equals to this side. Also, this side is parallel to this side, then this side is also parallel to this side. Is that clear? So the second one we're going to look at under this is opposite angles are equal. So this angle we have, so opposite angles are what, equal. So opposite angles are equal. So what we are saying in essence is that this angle here is equal to this angle here. Why this angle here is equal to this what, angle here. I hope that is very clear. So that is opposite angles are what, equal. So this one shows that the angles are not the same. The angles are not the same. So let's now look at how many lines of symmetry do we have in this one. So if we should close it, if I should divide it this way, if I should, sorry for that, if I should divide it this way, so if I should use this to divide it, if I should divide it this way, so this cannot overlap on this. So because this angle here will come and be touching it at this place, it can't overlap on this place. All right. So also if you divide it the other way around like this, so this cannot overlap on this one. So in that case, so we can say that this one has line of symmetry. So and also if you divide it this way as well, so it will not overlap. It will not fit into the other one. Exactly. So but if you look at this, if you cut it this way, if you cut it this way, so we're going to have, you can see that this side here is smaller than this side. Therefore, this will not overlap on it. While also this side is smaller than this side, it will not overlap on it. Is that clear? So it cannot, you can't fold it. When you fold it, it will not overlap. It will not fit into the other. Is that clear? That is what we are looking at. But if you cut it and rearrange it to overlap, but we are not looking at that. We want to, when you fold it, will it overlap? Will it fit into the other side? No. So that is the reason why we say that it has no line of symmetry. It has what? No lines of symmetry. So it has no line of what? Of symmetry. Is that clear? Then what about the order of rotational symmetry? So let's duplicate the shape and see what we're going to have. So if we're going to have the same thing, so this is the first, so 1, no, 2, yes, 3, no, 4, yes. So that is, it has two order of rotational symmetry. It has, so it has two order of rotational symmetry. Alright? Alright, I hope that is clear now. Then what test do we have to do here? We looked at lines of symmetry, then that is all on this one. So we then move to rhombus. So rhombus, under rhombus, all the sides are equal. So this equals to this, equals to this, equals to this. So we can have it to be all sides are equal. So all sides are what? Equal. Just like square. All sides are equal. Then what else again? We've looked at that one. Then opposite sides are parallel. Opposite sides are parallel. Opposite sides are parallel. All right. Then opposite sides are parallel. The other thing is under this is that opposite angles are also equal. So opposite angle. So opposite sides are parallel. Let me write that. So this side is parallel to this side. Then this side is parallel to this side. Then this angle is equal to this angle. This angle here is equal to this angle. But the angles are not the same. It's not equal to 90 degrees. So we come back to this place. So opposite angles are equal. All right. Then line of symmetry. So this, when we cut it here, when we cut it into two, this will overlap. It will fit in the other one. If we cut it again here, this also gives us the same thing. So it means it has two lines of symmetry. So rhombus has two lines of symmetry. So it has two lines of symmetry. All right, it has two lines of symmetry. Then the fifth one rather, it has two lines of symmetry. It has two order of rotational symmetry. So it has two order of rotational symmetry as well. No. So let's say it's going to have four order of rotational symmetry. It's going to have four order. Four. It's going to be four orders of rotational symmetry. Four orders of rotational symmetry. Rotational symmetry. All right. Hope that is clear. So let's demonstrate that. Let's demonstrate that. Let me duplicate this and then let's bring it here. So let's duplicate this. Okay. So if we bring it here now, so let's rotate it and see. If I should rotate it, still come back to the normal one. Rotate again, still the same thing. Rotate again, still the same thing. So that's how it's going to look like. Alright. So it has four order of rotational symmetry. So the next one is trapezium. So under trapezium, we have about three types of trapezium. So we start with the first one, which is isosceles trapezium. What does that mean? So the pair of sides here, the two sides are equal under this one. Then it has one pair of parallel sides. So the first feature we're going to have there, so it has one pair of parallel sides. All right, so that's the first one. So and it has one pair again. It has one pair of equal size, right? And the adjacent size, the adjacent angles are equal here. So what does that mean? So this angle here, this angle equals to this angle. Then this angle equals to what? This angle. So adjacent angles are what? Equal. So adjacent angles are equal. All right. Then line of symmetry under this. So when you divide it like this, it overlaps. So it has a line of symmetry. It has a line of symmetry. It has a line of symmetry. Right? It has a line of symmetry. So what about order of rotational symmetry? Order of rotational symmetry in this case will be 1. It has one order of rotational symmetry. All right. Okay. So and that I think that's all. So for the second type that we have there, so we have right angle trapezium. So this one is just repetition of what we have there, but there will be removal of some. All right. So if we come here, is it has one pair of parallel side. That is correct. So this side here, this side is parallel to this side. So it has one pair of equal sides. So this one has no pair of equal sides. So this will be out of it. Alright. And then adjacent angles are equal. No. So we have this is out of it. Alright. Then it has a line of symmetry. This it has no line of symmetry. This one has no line of symmetry. The order of rotational symmetry. So let's look at it together so that we see what I'm talking about. So whether it's going to have it or not. So we see it by ourselves. So the first rotation, no. Second, no. Third, no. Fourth, no. So it has one order of rotational symmetry. Alright. So then, so it has a right angle. It has two right angles. So this angle here is also a right angle. So it has two right angles. It has two right angles. So it has two right angles. Right angles. So that's a line of symmetry. So the third one, which is scaling trapezium. So under scaling trapezium, so this is how this one will look like. Let me draw that. So scaling trapezium is a trapezium whose size, all the sides are not the same. You can have it this way. You can have it this. You can have it this way like this. So all the sides are not the same. So you have 1 here, 2 here, 3 here, 4 here, but it has one pair of parallel sides, no line of symmetry, and one order of rotational symmetry. So for this, it's going to be all sides are not equal. All right, then it has no line of symmetry. All right. Um, it has one order of rotational symmetry. It has one order of rotational symmetry. All right. Okay. So that is that. So it has one pair of parallel sides. it has one pair of parallel sides. So the most important thing in this thing is for you to be able to. That is why I'm doing it with you. I cannot just give you the properties and say, okay, go and learn it. No. So that's why we are demonstrating it one by one. So the last part is kites. So we want to look at kites. So kites is quite different. Kites and rhombus looks alike. They almost have the same property. All right. So we're going to look at that. So let's look at that now and see if they have the same thing or not. But they are not the same. So there are some that are quite different. All right. So we look at that now. So let's have this. All right. All right. So kites. So let's draw the kite first. Let's draw it first. So let me use black. So kites will look like this. You can see that it looks like a rhombus, but it's not a rhombus. Why? Because the side above are the same and the side below are also the same. But in a rhombus, all the sides are equal. You understand? So there is no parallel sides here. So none of the sides are parallel. Exactly. Then you can say that. So we can have this. So let's all sides are not equal. So this one means that the adjacent sides, two pairs. So we can have it two pairs of equal adjacent size. All right, that's the first one. So then a line, it has a single a line of symmetry. So opposite side, we erase all these ones. So here, this is going to be, it has this line, it's only this line that divides into two. So it has a line of symmetry. It has a line of symmetry. So it has a line of symmetry. It has a line of symmetry. Alright, then the diagonal. So there are some, I'll say go back to some at the top here. The diagonal. So a diagonal is a line drawn from one corner to the other. So diagonal bisect at 90 degrees. So we'll go back to that. So diagonal of this one bisect. So the bisect at 90 degree, they form angle 90 degree at this place. At this place, at this place. So diagonals bisect at 90 degree. Alright, so diagonal bisect, that is divide, that's what it means, bisect at 90 degrees. Then order of rotational symmetry, it has one order, 4. So it has one order of rotational symmetry. Alright, it's okay. It has one line symmetry. What else again? So the opposite sides are not equal. So it has one side that is equal. So which is only this side that is. So this angle, opposite angle rather. So this angle here equals to this angle. It has a pair, number 5. So 5. So it has a pair of opposite equal angles. I hope this is clear. So let's go back to this okay, let's come back to this place, to rhombus. So this one, diagonals bisect at 90 degrees as well. So you can see it's exactly 90 degrees. So diagonals bisect at 90 degrees. Diagonals bisect at 90 degrees. Is that clear? So then we go to rectangles. This one too. Let's copy this. So let's go to square. Rhombus. Okay, that's rhombus. Parallelogram, they are not bisecting at 90 degrees. Uh, square. Square. They are also not bisecting at 90 degrees. So that is that on that one. I hope you find this video useful and helpful. So make sure you watch the video very well and make sure you make notes on it. So we're going to meet in our next video. Bye for now.